All right, these are double replacement reactions. This is the first kind of problem where you have to actually predict the products. So this looks a little complicated. It's AB plus CD equals or yields AD plus CB. Now, check this out. What's the charge of A always? Positive, right? The first thing's always positive. These are all ions. B is going to be what? Negative. C is going to be positive, and D is going to be. So there's only one way that they can rearrange themselves, right? So we have positive would then go with the other negative, and then the negative would go with the other positive, and that's how you end up with A and D together, and then C and B together. The positive one always goes first, right? So that's why C goes first instead of it, being the other one. All right? That's kind of all you have to do with these ones. These involve mixing two ionic compounds. That's why they always have charges, and they're also always dissolved in water. So the reactants are always going to be aqueous. All right, so in water, ionic compounds dissociate into their ions. What does dissociate mean? Yeah, basically to break apart. All right, so they basically will break apart. So if you had NaCl solid, and you dropped it into a glass of water, H2O, what's going to happen is, once it's in there, the Na is going to break apart, and the Cl is going to break apart. So they're going to be floating around in there, and then they're going to be able to interact with the other positive and negative things that are in there that you're mixing, and that's where we get back into this. Sodium chloride could be one of them. Whatever the other thing is going to be in here, that'll also mix, and then a reaction could take place. Sometimes it doesn't take place, but we'll talk about that when we get there. So our first example would be this right here. What's the name of this? What would we call this? AgNO3. What's it? Yeah, silver nitrate, right? Silver's an exception, so you don't use Roman numerals. So it's silver nitrate. What would this one be?
Potassium chloride.
Potassium chloride, good. And they're both aqueous. Now, how do we know they're both aqueous? How do we know? Jacob?
If they are in a double replacement reaction.
Yeah, actually, that's not a bad way to think about it. The reactants should always be aqueous. That is true. The products, we don't know. Now, there's something else. You should check this chart, all right? This is how you actually find out, is there's a chart. It looks intimidating, but it's not. The first one's silver nitrate, right? So silver, let's find our silver. Okay. I was looking for S. Silver, Ag, all right. And then NO3, nitrate. And then you see how it says S here? What does S stand for?
Soluble.
Soluble, yeah, soluble.
Oh, what?
Soluble. Doesn't mean solid, right? What does it mean if something's soluble? Yeah, able to be dissolved. Or if it's in water, it's going to be aqueous. How terrible is it that this chart uses S's and they don't mean solid? Right? I know. I don't understand why they do it. It should be like an aqueous table. But that's why, because it's a solubility, so it's soluble. All right? You guys do have it, right? It's at the end, maybe? Yeah? All right, cool. So then we'll check the other one. We have KCl, K, potassium, K. And then what do you notice about all the Ks? Yeah, so we don't even have to find the Cl, right? Because it's going to be soluble. So that would be, if we did care to look for it right there. So yeah, they're both going to be aqueous, all right? You have to check this chart again with the products to see if the same thing's true. Yeah?
Do we have this chart?
Of course. In AP chemistry, you will not. But there's trends for you to remember how to do it. Like, for example, all group 1 metals are soluble. So that's like sodium, potassium, sodium, potassium. So you don't have to remember them. You just have to remember like trends. There's like 7 rules for remembering that stuff. All right. But again, you will always have this chart.
How come like hydrogen and hydroxide has nothing?
Sometimes when they're blank, it's because when you combine them, they actually decompose into something else, so you can't use this chart for it. So that's the reason that some of them are blank. And this is a simplified version of the chart. There's a more complicated version also where things can be slightly soluble as opposed to being soluble. So we simplified it in here. Notice also, sometimes you have different charges for things. Actually, on this chart, they simplified that as well. There's sometimes when you have like iron 3 and iron 2, they have different solubilities, but we're not going to worry about that. All right? Okay. So back to this chart, or back to this problem. What are the products going to be for this? What's silver going to now go with? Yeah, the Cl. All right, so this, come on. And then the K is going to go with the NO3, right? You're embarrassing me, Marker, in front of the camera. Come on. Okay, so these two are going to go together, these two are going to go together. All right, so let's write it out. So Ag, that's positive, is going to go with the Cl. Now you have to make sure that their charges work out. In this case, they do. They're +1 and -1. So it is going to be silver chloride. We'll have to check the chart. Plus potassium and NO3. KNO3, it's +1 and -1, so that's also balanced. And then we have to check the chart for this as well. So when you check the chart, what do you find out? Let's see. What was the first one? AgCl. Let's do that first. So Ag and Cl came up with an I, right? I means it's insoluble, which means it's going to be a solid. How confusing is that?
Wow.
All right, you get an I on the chart, it's a solid. It means that it doesn't dissolve in it, so it's insoluble. So then it's going to be our S here. All right, and then what about the other one, potassium nitrate? Yeah, Jacob.
Aqueous, because
It's gonna be aqueous, right?
potassium is-
Yeah, exactly. So if you start remembering, all right, it's a group 1, it's always going to be aqueous, and that's really good. Also, if you look at nitrates, nitrates are always going to be soluble as well. So as we do this chapter, you'll start remembering things like that, where, okay, if it's a nitrate, it's going to be soluble. If it's a group 1, it's going to be soluble. You'll start like seeing trends in this. Even though it looks like mass chaos, you'll start to see some patterns, all right? So we said it was aqueous. Come on. Aqueous. All right. Any questions with that? Okay, this is what it would actually look like. Not like a bad Microsoft Paint drawing, but it would be, when you combine both of them together, the thing that's aqueous would stay floating. You wouldn't be able to see it. And then everything else would sink to the bottom. It would precipitate out. It's almost like it would snow out of it, all right? You've heard of precipitation for rain, right? Or snow means precipitation. In chemistry, it means the same thing. This would precipitate out or become the solid in there, all right? We're going to do a lab where we get to see this in action. Good?